Question 12 says the length of a piece of wire is measured as 4.5 centimeters. Calculate the tolerance. So this topic is under estimation. So now look at this measurement. So this one we call it the true measurement, right? It's a true measurement, which is 4.5. Now we need to find what we call the least unit of measure. The least unit of measure. The least unit of measure of 4.5 is 0.1. The least unit of measure of 4.5 is 0.1. So now, look at this. How do we come up with this least unit of measure? Take note that how do we come up with the least unit of measure? Take note that for any whole number, like 4 or 100, as long as a whole number without the point, the least unit of measure will be a whole number as well, 1. If we have a 1 decimal number, if we have a decimal number with 1 decimal place, like 0.2, just know that the least unit of measure will also contain a decimal place, 0.1. You see, 1 decimal place, 1 decimal place. If we have 4.21, for example, 2 decimal places, even the least unit of measure will have also 2 decimal places. So the 1 will continue to be there, right? Let's assume we have 3.248. You see, we have 3 decimal places. Even the least unit of measure, just keep on adding until you have 3 decimal places. This is why this one had 1 decimal place. Even the least unit of measure will contain also a decimal point, you see, which is 1 decimal place, just like here. So now from there, so we are saying the least unit of measure for 4.5 is 0.1. Now we need to find the absolute error. Absolute error. You know, under this estimation topic, we are trying to find errors that people make when measuring. So you find that this was 4.5, the true measurement, but if we were to give someone else to measure, they might find something slightly higher or something slightly lower. You see that? So now, absolute error, you simply multiply half times the least unit of measure, which is 0.1, right? The least unit of measure, remember this, is 0.1. So you multiply. So when you write like this, same as 0.1 over 2. Now we need to find, you need to work this out. So 2 into 2, 1, 2 into 0 is 0, point, 2 into 1, it can't, write 0, also add a 0, it will be a 10. 2 into 10, it is 5. So the absolute error is 0.05. What does it mean? This absolute error, it means if we were to give someone to measure, they might, to measure this piece of wire, they might measure something slightly higher by what unit? By 0.05. Also, if you give a different person to measure the same piece of wire, they might measure something slightly lower by what unit? By 0.05. So when you say slightly high, it means you add 4.5 plus 0.05. When we say slightly lower, it means you subtract 4.5 minus 0.05. Now, tolerance. How do you find the tolerance? So after that, we need to find what we call the upper limit. Upper limit is what you get when you measure something slightly higher than the original measurement, the true measure, which is 4.5 in this case. So upper limit, you're going to add the 4.5, which is the true measure, plus the absolute error. So you see the point to fall under a zero point, this will be 0, 5. Let us add. This is same as 0 because write it as a place value, right? So 0 plus 5, 5, 5 plus 0, 5, point 4. You see that? So this is the upper limit. When this person is told to measure the same piece of wire whose true measurement was 4.5, this person can make an error of 4.55. It's an error because the true measurement was 4.5, but it's an error which has gone slightly higher by what unit? By 0.05, right? So we call it upper limit. Then let us also find the lower limit. There are times where they will ask you to find the lower limit. This is what you do. Lower limit, you subtract 4.5 minus the same 0.05, 0.05, just put a place value here, minus. So 0 minus 5, it can't, you get a 1 here, so here there will be a 4 remaining, a 1, put it here to be 10. 10 minus 5, you get 5. 4 minus 0, you get 4. 4 minus 0, you get 4. So this is the lower limit. You see this? So indeed, this other person has measured something slightly lower than the true measurement, which is 4.45. So we have the upper limit, lower limit. Now, tolerance, you simply subtract upper limit minus lower limit. Tolerance, therefore, tolerance subtract the upper limit, which is 4.55, minus the lower limit, which is 4.45. So 5 minus 5, 0. 5 minus 4 is 1. 4 minus 4 is 0. So the tolerance, same as saying 0.1. This one or this one, whichever. So this is the tolerance. This is what you are supposed to do. So question B is talking about finding the relative error. Relative error you simply have to do, you divide absolute error over the true measure, or the true value, or the true measurement. So absolute error, remember we found it, absolute error was 0.05, 0.05 over true measure is 4.5 as given in the equation, 4.5. So let us work out this one. So this is paper 1. What you have to do to divide these decimal numbers, you need to find a way of removing these decimal places, right? This decimal point must disappear. So what should you do? Now check at the decimal places on top and down there, on the numerator and the denominator. So which one has the highest number of decimal places is the one on top. How many decimal places do we have? Is there are 2 decimal places, so it means you multiply by 100 on this numerator. What you do on top, do the same down there, even here over 100. So 0.05 times 100, these 2 zeros, it means move 2 steps forward. So this point will move 1, 2. It means there will be just a 5 remaining. You see that? Why 5 remaining? Because if you had 0.05, then you move 2 steps forward, the point to move here. So you are going to have this. So what's the point of including these 0 zeros, these 2 zeros? No need. This is why I have just written a 5, right? No need. So now, mind you, our goal is to remove the decimal places, decimal points. What about this one? 4.5 times 100. it means you move 2 steps forward. These 2 zeros, it means move 2 steps forward. If we had 1 0, we are going to move 1 step forward. So if you have 4.5, look at this, 4.5, move 2 steps forward, it will be 1 2. So here it means we add a 0. So the point has moved to this, so no need of showing it, just write 450. So 4.5, it means 450. You see that? Now let us divide, let us reduce this. 5 into 5, you see there's a number which will go into 5 and 45. 5 into 5, 1. 5 into 4, it can't, so 5 into 45 is 9. 5 into 0 is 0. It means 5 into 5 is 1, and 5 into 450, it is 90. So as you can see, we have remained with 1 over 90. So you leave it like this. You can leave it like this. It is fine. Leave it like this as your relative error, right? So now, what if there are times where they will ask about percentage error? There are times where they will ask about percentage error. Percentage error, you simply use, you say relative error just times 100, because percentage is out of 100. So you simply do that. So in this case, our relative error was 1 over 90, so times 100. You see that? So now you cancel a 0 here and a 0 there. There you go. So you have 1 times 10, you have a 10 over 9. So 9 into 10, what do you get? It goes there once, remainder what? 1 over the same 9. You put percentage as your percentage error. This is what you're supposed to do.